Great. Okay, so let's get started. This presentation is about how to build your annotation processor with KSP. KSP stands for Kotlin Symbol Processor. It's Google's new tool for writing annotation processors. But first, you might ask, do we actually still need annotation processors in 2021? So we all know that build times are a problem for Android apps, and each annotation processor you add is contributing to the build times. And then in the dependency injection space, you have a very heavyweight solution, which is Dagger 2, that uses annotation processing. And then alternatives like Coin have come out recently where they don't use any annotation processing at all, and they're very popular. And lastly, we know that hardware performance is improving. So historically, we've avoided annotation processors because the performance of the alternative, which is reflection, is very, very bad. Now, I wanted to investigate the last point, but in any case, if you have doubts about whether we still need annotation processors in 2021, you're not alone. This was recently asked on r/Android Dev. I wanted to investigate the performance aspect. So if we look at the market share of phones in the United States, you can see that Samsung flagship phones from 2 or 3 years ago are the most popular ones. And this is a story that plays out in other markets as well. So if I take an S9 and run this benchmark, this is Zach Swear's JSON serialization benchmark. It's just going to run a whole lot of tests for JSON serialization on your phone and measure the time. We can discount this JSON reflective solution because it's inherently unsafe. So this JSON reflective solution won't actually respect Kotlin nullability. But if you look at the other solutions, you can see that reflective solutions are slower, but we're not talking slower by being twice as slow. That kind of performance hit might actually be acceptable to you if you really want to reduce your build times. So even if we discount performance, I think there's still some reasons that we'd want to favor annotation processing over reflection-based solutions. First of all, that reflection and minification are like the Capulets and the Montagues. They're antagonists. Reflection relies on the full class information and the metadata being present, while minification is desperately trying to strip that. We can't do without minification because we're very concerned about APK size. So that's one reason that we might want to avoid reflection. Also, if you do end up using a reflective solution, Kotlin.reflect is a very large artifact that you might have to end up including in your APK. And lastly, we want to fail fast. Ideally, we want to fail or crash when the developer is smoke testing using their debug builds. We don't want to have to, we don't want something that's passing on the developer's debug builds, and then when it gets to a minified release build, it crashes because minification has stripped out something that was necessary for the reflective-based solution. But what if you could have both? What if you could have fast builds and then failing fast, failing at compile time, like annotation processors will let you? For that, we have KSP, which was announced at Google I/O earlier this year. And you might think, okay, stop trying to make KSP happen. It's not going to happen. Well, KSP is happening. You can see there's support for experimental support for Room and Moshi, which are very, very popular annotation processors. And there's planned support for the big ones, Dagger and Glide. So KSP isn't a silver bullet. Just converting one of your annotation processors from the legacy system, which was kapt, to KSP, might not improve your build times very much. What we're aiming for here is to completely eliminate kapt from your Gradle builds, like in this tweet from Zach Swears. Now, this tweet talks about the reason why the legacy solutions kapt are so slow, which is this stubs generation. I wanted to find out more about this, so I took the Sunflower project from Google and I threw my Pokeball in order to catch a stub. And the Pokeball opened inside the app/build/temp/kapt3 directory. We have a Kotlin class that looks like this, so just a regular room entity. Then the stub looks like this. So you can actually see that this setter here, which is generated from the var in the Kotlin code, is stubbed out just like you'd use a stub in a test. This method body is empty. It doesn't actually do anything. And generating these stubs is actually very costly because it requires the compiler to resolve the symbols in your program, once for generating the stubs and then secondly for continuing the compilation. So we'd like to avoid the stubs. Stubs are necessary because the Java annotation processors see your Kotlin code but through a glass darkly. So they see your Kotlin code through the medium of the stubs. They generally use an API, the javax.lang.model.element API to access and inspect your code. And that for that, you're required to use stubs. However, KSP, we don't need that. KSP sees your Kotlin code directly. And so because it doesn't rely on the stubs, it's much faster. And we're going to have a look at this now when we actually build a toy annotation processor. So I'll just switch to the IDE. Let's start by looking at the project structure here. Now we've got a project with 3 modules. We've got an annotation module, a consumer module, and then a processor module. So just start by looking at the annotation. We've declared an annotation called int summable. We're going to show you how to use that later. Now the retention is source. We want it to be accessible to annotation processors, but we don't care about it being present at runtime, and we don't care about it being present on the bytecode or not. And this annotation is going to target a class. We'll look at the processor now that's going to use this annotation. So start by looking at the build.gradle. In order to write an annotation processor that uses that int summable, we of course need the KSP as a dependency. We're also going to use Kotlin Poet to write the Kotlin code because it has such a nice fluent API. And Kotlin Poet has actually got a KSP artifact that allows for interop with KSP. You do have to opt in for that. And lastly, to test, we're going to use this Kotlin compile testing artifact here, which you might have seen if you've written a legacy annotation processor that uses kapt. Let's get on to our test. Now I've just set up the skeleton for a test here with the class and a rule for creating a temporary folder, and then just some helper methods that wrap the Kotlin compile testing API. So start by writing a test. Now we're going to start with a source file, the input for the annotation processor. It's a Kotlin class and it's called foo.kt. And then we have some contents. Get rid of that. So we need a package. And then we just have a data class called foo. And some properties that are ints. And we're going to annotate that with int summable. So that's our input for the annotation processor. Now, when we compile that, we want to end up with something that looks like this. So assert source equals is just a helper method I wrote that gives you some language highlighting on an assertion. So the expected will be something like this. We want the code to be emitted in the same package. And we just want to write an extension function on foo called sumInts, return type of int, and it's just going to be x plus y. That's the expected, and the actual should be compilation result source for foo_x.kt, like that. Okay, so let's try running our test. You can see it's going to, why is it failing? Okay, it's failing because we haven't supplied a symbol processor provider. So that gives us a clue about what to do next. We have to write a symbol processor provider, which is like an entry point to our KSP processor. Let's do that now. We're just going to add a main source set. And we need a package. I've been using this com soncar KSP example processor package. And then new Kotlin file, int summable processor provider. And we want that to implement symbol processor provider. What's IDE complaining about? Well, we haven't implemented all the members in order to comply with the interface contract. So let's do that now. Just have to implement this one member, which is create. Now, the symbol processor provider is like a factory for constructing your symbol processor, the annotation processor. And you get supplied a parameter called environment. Environment has a few goodies inside it. It has a logger for logging errors and so on, and it has a code generator. So that, again, that gives us a clue about what to do next. We actually need to create a processor class. Let's do that. Int summable processor. And this implements symbol processor. What's the compiler complaining about? Well, okay, again, we haven't implemented the members, so let's do that. Now we need to think about because we're using a factory, which is the processor provider, we need to think about what constructor parameters we want. So we're going to obviously need the code generator because we're writing code. And so we'll add that. And then we also need the logger. So let's add those. And we'll just clean that up, put them on separate lines and make them private. All right, so now we can go back and write our symbol processor provider. So we can get rid of that to do. Oops. And then return int summable processor. Just like that. And we could convert that to an expression body to make that a bit nicer. We could even convert that class to an object because there's no constructor parameters, but we won't do that right now. Okay, so now we've got to our processor. We've got to write this process method or this process function. Let's have a look at the doc there. So process is called by KSP to run the processing task. Okay. We get a resolver, which allows us to essentially inspect the code. And then we have to return a list of deferred symbols that are unable to be processed. And we're not doing any deferred processing here, so we can just return an empty list. And now all we need to do is start processing. And the first step is to find the symbols with the int summable annotation. We can use this get symbols with annotation function. And if we look at the doc there, you see you just have to provide a fully qualified name. So we can do int summable class qualified name. We'll just do double bang for now, but you could easily write a require qualified name extension function there. Not all classes are going to have qualified names, like if they're an anonymous class, but we do know that int summable will have a qualified name here. Now we need to start doing our actual processing. So we'll just use for each there. Now, processing in KSP is normally done with visitors. So we look at this KS visitor. You write a visitor that can visit the various elements in your source. This KS visitor has got two type parameters. It's got a D for data, which is what you supply as input into the, when you visit an element, and then result, which is the result of visiting. So when you finish visiting the node, it's going to output the R there. Now we don't actually need those, so we can actually derive from KS visitor void, which is like a convenience class where the type parameters are bound to unit. So visiting in a KS visitor void is just going to have some kind of side effect. It's not going to provide any output, and it's not going to require any input. And then what do we need to override? Well, we need to override visit class declaration, because int summable is going to be on a class declaration. We don't need the super there. Now, first step, I think, is to check whether we are actually targeting a data class or not. So how do we do that? We look at the modifiers for the class. So in the case that it's not a data class, what we can do is actually output an error. First parameter for error is the message, and the second parameter is the node. So specifying the node enables a nice error message with the line number and so on for consumers of your annotation processor. Right, what's our next step? Well, we need to get the integer properties of the class. So we could do something like val summables equals class declaration get all properties. Let's filter out the extension properties, because we could get into trouble with some kind of extension function that is, extension property that is very expensive. So we won't worry about that one. And then we want to filter, we want to specify the properties that are of type integer. So it type resolve is assignable from an integer. Now we need the type for integer here. The way to do that is to get the integer type from the resolver. So the common Kotlin types like string, integer, long, float, and so on are actually inside built-ins inside the resolver. So we'll declare a var int type. We can assign that here in the resolver built-ins int type, just like that. Right, so now we've got all properties of the class except extension properties, and we've made sure that they're integers. Now this is a sequence here. Let's actually just materialize that as a list just to make our lives easier. Now we can do if summables is empty. It's nothing for us to do. We can just return. Now we need to start writing our code. A way to do that in Kotlin Poet is to use a file spec. File spec describes the file you're going to be writing. So the package name is going to be the class declaration package name. See, package declaration is a KS name. We can convert that to a string with this as string function. And the file name is going to be foo extension. Oh, well, actually, no, it's going to be class declaration simple name as string x, like that. Right. So we've got a file spec. What do we want to put inside? Well, we want to put a function. And we build a function using funspec. What's the name of the function? It's some ints. The return type is int. I'll just do a build there so we can make sure we're getting some checking by the compiler. And the receiver, okay, receiver, for specifying the receiver, we only are allowed to use one of these here. And these are all Kotlin Poet types. So we need some way to convert the KSP type into a Kotlin Poet type. We can do that using class declaration as type. And then we're just going to make our lives easier for now and ignore any type arguments. And to type name. So this is going to convert the KSP type into a Kotlin Poet type name. Now we've got the return type and the receiver for our function, but we don't have the body. So we need to add a statement. So we're just going to do return %L. %L stands for literal in Kotlin Poet. Like this is the general Kotlin Poet API. And what do we need to supply there? Well, it's just the summables and join to string with a plus like that. And then build. So we've built the function. Now we just need to build the file spec. So building the file spec isn't enough. We need to write. So we need to write this to the KSP code generator. And we're not worrying about whether it's aggregating or not. And that should be enough to just run our processor. Of course, we have to actually use the visitor. So accept my visitor and just supply unit. Right, let's see if our test is going to pass or not. So we do need to summable processor provider. Okay, we got somewhere. Failing test. Now, this was the expected, and actual looks something like this. So what this means is that Kotlin Poet has actually added the import statements, which is great. So we just need to fix our test. So instead of just expecting something without the the imports, we change our expectations so that we are expecting the imports. Let's run it again. Okay, so just some very minor indentation problems there. But yay, okay, our test passed. So that's our annotation processor. Now, one thing I neglected to mention is that we need some kind of service discovery for your symbol processor provider. You can do that using auto service. What type of service are we declaring? Well, we're declaring a symbol processor provider like that. The other way to do that, if you don't want to use auto service, is to declare a folder a meta imp file in the resources directory. But I found that to be a little bit error prone. I really like this auto service artifact from Zach Swears. So now we should be able to look at our consumer and actually run our annotation processor. So inside our consumer, I've added KSP as a plugin, and I've said, hey, this processor module contains a KSP project. Let's see if we can get that to work. So just go build, and hopefully if we uncomment that, yes, so we see that the summons directory, or the summons extension function has been generated by KSP. Right, so that's all I wanted to talk about in terms of the code example. Are there any questions?
Hey, we can give everybody another minute to write anything if they have some. Yeah. How do you feel that went, David?
Yeah, that went okay. I should say that if you search for fact or kapt, which is the name of this conference talk on Google, then it should come up with a Medium article where it goes through basically what I've talked about in the presentation and explains everything. And there's also a link to the GitHub repo there where there's a fully functioning example for you to play with.
Yeah, I mean, oh, we got one. We'll give people maybe another, before start answering Saba's question, give people another minute. Yeah, I feel like for me, I've never really dealt with, like I've never had to build anything or do much with annotations. I don't know, maybe it's the project I've been on for the last while. It's just been overly simple, and I know I'm still young in my career, but it's where it gets difficult for me to, I think, like, understand the importance of annotation processors. It's like I've never built one. You know, like what's a case where you've found you need to start building your own?
Right. One project I've worked on, there was a mapping between various layers, between the data layer and the domain layer, and that mapping was done using annotation processor, and it was a legacy processor using kapt, and it was quite hard to maintain. There's generally annotation processors are good for cross-cutting concerns, so something like an A/B testing framework that you use all over your project, or some kind of configuration, like like say you have some developer options and you want to expose them and have them deal with different parts of changing the behavior of your project. Like that might be something you would use an annotation processor. So the other thing to note is that you don't have to use KSP to emit code. You can just use it to perform some kind of compile check. So there's some kind of check that you can't actually express as a lint rule, then that would be another use for KSP. You can run KSP on your project and then use the logger error function to highlight some kind of error for which you want the compilation to stop.
Interesting. Yeah. I mean, the idea of like adding like a compile time check for a case where if you can't put a static code analysis check. That sounds interesting. All right, it seems like the one question we have is from Saba, so I'm gonna put that on stage and let you answer it. Oh wait, I think did I by mistakenly take your question, Saba? I swear I didn't read it first. But I mean, do you feel like is there anything more you want to add to it since it's a formal question from Saba, David?
Yes, I think that's a good question. So you would have seen that in the presentation. I gave a stupid example of an annotation processor that's really just a toy, and that's for the purposes of demonstration. Like you often encounter this problem where you try and build something really useful, it's just too complex to demo within half an hour. But if you build something simple, it just looks like a waste of time. So like I said before, annotation processors are useful for cross-cutting concerns, something that you're using all across your project, and you don't want to just write out the same code every time. So a classic example is dependency injection. Dependency injection is a cross-cutting concern. It doesn't concern one particular class. It concerns the whole way you organize your project. And like we said previously, you don't have to use KSP to emit code. You can use it to perform some kind of compilation check. Like if you have a large team and you're trying to prevent people from encountering some kind of bug, you could certainly use KSP for that if you weren't able to use a lint. Maybe even more detail about that object translation or A/B testing annotations or configuration annotations. I think it's hard to go into too much detail without actually revealing something that you would not want to reveal, but the kinds of problems that are solved by annotation processors usually emerge for larger teams, I would say. So larger Android projects, if it's just one or two developers, you might not need to write your own annotation processor. You can probably just get by with the annotation processors that are provided for you, like Dagger 2 and Glide and so on. But if you look around at what kind of annotation processes have been written, you can see there's one for like loading images, which is Glide. There's one for deep links, Airbnb's deep links dispatch. There's one for recycler views, which is Epoxy, and that gives you an idea of what kind of things you can do with annotation processes and what kind of problems you can solve.
Okay, I'm going to mark that one as answered. And then Saba asked one more question. Or I guess it's more of asking for an elaboration on what you were talking about.
Yes, I think I've answered that with what I said just now.
Okay. Then we can go back to the tables. David, thank you so much. Like this is, I think what the reason for the lack of questions is this is an advanced topic, and advanced topics are more difficult to get a significant amount of questions about, but they're super important for the for the progress of our field. We can't always stay on intro topics, and because those ones are nice, fluffy, and get the most attention. So thank you so much for getting into this.
Yeah, no problem. I would say that this stuff takes a while to digest. Like certainly for me, when I was learning this, it took a while. So good thing to do is to look at the example project on GitHub and then run it, use a debugger, and find out what's going on at every stage, and then you'll get a good idea of how to use KSP.
All right. Then we'll call that a wrap. We'll go back to the tables. We'll hang out. Next talk starts at, I don't know, what is it, like 38 minutes? I don't know. Maybe I'm doing math poorly. Let's call it 38 minutes. And if I'm wrong, math. All right, guys. Take care. Bye.
Thank you.